Thank you for the introduction. I'm very excited to be here. It's always a privilege to be, amongst professionals and colleagues, around the world, sharing information and exchanging ideas. So I look forward to an exciting time today, and I hope my presentation will be able to shed some light on the applications of blockchain for cybersecurity. So the topic is blockchain for cybersecurity, blockchain in cybersecurity, getting beyond the elevation, which is, what is the next stage? Applying the blockchain, its benefits to cybersecurity. What is beyond that elevation? What are the benefits? What are the advantages? What is the way forward? What's the future? And I'm going to start by introducing myself. My name is Bolabo Awelewa. I'm an information security specialist. I have some experience with enterprise information technology, technology infrastructure. At some point, I was an enterprise security architect, and I've worked in roles of being a chief information security officer. With I think a major advantage is my vast experience in technology management, and I'm a bit of a fintech enthusiast, which is leveraging digital technology and seeing how best to use it to drive profitability and efficiency, in your business. So to get things rolling, so I think it's the easiest way to start is, understanding what the blockchain is. And it has a lot of meanings, it has a lot of applications. For example, people think blockchain and the first thing that comes to mind is Bitcoin. But the blockchain is the technology on itself which Bitcoin is riding off. So I would, so there's a definition, from The Economist that jumps out to me every time is, and it says that to understand the power of the blockchain system and the things they can do, it's important you distinguish three things that are commonly modeled up, which is, namely the Bitcoin currency specific blockchain that underpins it and the idea of the blockchain in general. So the Bitcoin currency rides, on blockchain itself. And then the blockchain generally is it's a technology that permits transactions to be gathered into blocks and records. It allows cryptographic chain blocks, in a chronological order, and it allows the resulting ledger to be accessed by different servers. So the question now is, what is a ledger? But before we go to the ledger, so let's look at how the blocks are arranged. What's that concept of an arrangement or alignment of, cryptographic blocks? So basically, it's a block after the other, and each blockchain contains a hash. So we'll come back to this. We'll see the benefits of the hash in the first place. So I'll probably be moving a bit fast, but just to save time. So it contains a hash of the previous block's data. And this is exactly what ensures that the chain remains immutable. When it's impregnable, changes can be made because any change in a block's data will invalidate every block that follows it. So basically, what is that? What's the technology? What's the concept that makes the blockchain, unalterable? What drives transparency in the blockchain is the hash function, making it immutable, ensuring that you can't to be difficult to make changes without authorization, because every change made on the block, any change in the block's data will invalidate every block that follows it because they are linked to each other by the defined hash as follows. So going back to what a distributed ledger is. So what is the ledger? So so there's a centralized ledger. So using an example of bank operations, for example, centralized ledger, here you have multiple ledgers, but the bank holds the golden record. Basically, it's saying you are storing everything in a central location. There's a central repository where everything is stored. So client A, client B, all is central. So client B must reconcile its own ledger against the bank and must convince the bank to basically all entities resolving at the center, one after the other. So that's the past. So the future now, distributed ledger, which is the blockchain. And by the way, some financial institutions have started leveraging on this too. So there's one ledger and all nodes have some level of access to the ledger. And then all nodes agree to a protocol that determines the true state of the ledger at any point in time. So the application of this protocol is sometimes called achieving consensus. So basically, it is one ledger, and all nodes have agreed to work together on this ledger. Changes, updates, passed across, transparent, can't be changed without authentication or authorization. And you achieve a consensus before you agree that, okay, this is the current state based on the changes that have been made. Consensus has to be achieved. That alone is a security function. That alone, puts some level of control in ensuring that, and the posture can be changed and the state cannot be changed beyond what it should be. And so basically, how might the distributed ledger work? So looking at the different stages. So the transaction is initiated, obviously, definitely using digital signatures. The users broadcast their transactions to all the nodes on the ledger. And one or more nodes begin validating each transaction. So validation across board, and validation is aggregated and it's built up into a block. And the nodes broadcast block to each other, basically. And the consensus protocol is used. That is where they achieve consensus. At that point in time, the block is reflecting the true state, prior to the block. So, and that is what defines different stages and different activities on blocking. A more descriptive way of looking at it, this is how the blockchain works. So basically, someone makes a request. So the request is passed, is broadcasted to every node. So point-to-point network, peer-to-peer network, consisting of computers known as nodes. So all these nodes know each other and they've agreed to run on the chain. And so it passes through a validation process. So at this point in time, the network of nodes validate the transactions and the user status using known algorithms. So there are defined algorithms on the blockchain already. And so during the validation process, you verify, and the verification process will involve cryptocurrency, contracts, smart contracts, system around records and other information. And so once verified, the transaction is combined with other transactions to create a new block of data for the ledger. And then you move on to the block. So the new block is then added to existing blockchain. So the blockchain comprises of multiple blocks. And for every transaction, for every engagement, a new block is set up. Once it passes through the process of validation and verified, and in a way that's permanent and unalterable when it comes to block. So at that point in time, transaction is complete. The other stages are the parts when it links to cryptocurrency, which is a medium of exchange, which is not necessarily the subject of today's topic. But basically, this processes define and gives it that value of transparency and the integrity that is required. And it passes through multiple verification and validation processes to ensure that information is accurate, data is accurate. So you'll be wondering, so at what point would the blockchain use cryptography, because it's mentioned, because that is actually one of the major security controls on the blockchain. So at the point where it's initiating, and broadcasting transactions, a request comes through, leverages on digital signatures, private and public keys. At the point where it's validating the transaction, because there has to be proof of work and other alternatives. And at the time when it's chaining the blocks, which is adding a new block to the set of blocks, the hash function comes into play, which is where all the blocks are linked through the hash function. So to delve deep into the digital signatures bits, hash function and certificate keys used in the whole process. So this just shows the different staging. So there's a signing, leveraging on the hash function, the data file comes through, it is signed and it's passed on the private keys are signed, a digital signature is assigned. So once it's digitally signed, the next stage is verification, and to verify, you'll be verifying using the hash function to confirm the correctness, using the public key to confirm correctness of the digital signature. All these controls, all these different stages is what makes the blockchain more secure, for a particular transaction, and makes it a very good feature to be able to enhance cybersecurity capabilities makes it a better cybersecurity tool going forward, depending on the cybersecurity challenge or the vulnerability you're trying to remediate. So we'll move straight into the blockchain, implementing blockchain as a cybersecurity tool. It has a lot of applications, different ways you can apply the blockchain as a cybersecurity tool. So we're looking at the blockchain features. So we'll be talking about some of the features. So based on the framework of the blockchain that is built on, it would help in developing effective controls to achieve, the triage for cybersecurity, which is confidentiality, integrity, and availability, including non-repudiation. So, that's for every cybersecurity specialist, that is top of mind for us. Confidentiality, integrity, and availability, and non-repudiation. And how do we leverage the blockchain? How do we apply blockchain technology to ensure that can be achieved? So some of the benefits, some of the features of blockchain technology, which is no third-party involvement, unalterable copies only, real-time tracking, it's transparent, it's open, it's real-time, it's always available. It's more secure. There's no single point of failure. Why? Because it's distributed, different blocks. It's not centralized. It's transparency, as mentioned, reduced cost, especially cost of operations, and there's a trust element between each node, between each entity, based on validation and verification, and the fact that it can be altered. And then, so we'll move on to how the blockchain can transform cybersecurity. So there are a lot of ways. So I picked this from one of the blogs I followed, the Disruptor Daily, and then there are different applications for the blockchain. A lot of applications for the blockchain that can help transform cybersecurity management. And there are a couple of them. Today we'll be picking on we'll talk about mitigating DDoS attack, and then we'll probably talk about some other entries. So, but starting with verifying software download. So a major issue we have, with software usage, downloads, and updates is the presence of viruses and worms, Trojan horses are right into our computers. When we download some of this software application, try to install them. Year on year, different malware, different viruses are being put into systems. It affects those systems. And the major issue has been, how do you verify, how do you confirm that the update you are downloading or the software you are downloading from that app store or from the repository is legitimate? And that is where the blockchain, comes into it. The blockchain has the potential to assign unique hashes to downloads and updates. This would allow users to compare the hash on their would-be downloads with the developer's hash to significantly reduce their chances of infecting their system with fraudulent software or well-disguised malware. For me, this is a very critical function. This is a very critical service. It will, at least eliminate to a very great extent for the unknown, for the uninitiated, or for the unsecurity savvy user. Some level of verification will be done, and and it has to be automated. So once the system can detect that, okay, this software based on the hash provided by the developer, you can't verify, and then it doesn't let you download that, it doesn't let you run it on your system, and the system is more secure. That's a very effective use of blockchain in cybersecurity. So we're coming back to the DDoS attack, mitigating DDoS attack. Another very effective use of the blockchain is in biometric and private keys. So it's a major issue, managing keys, managing identity. But the major advantage is that the blockchain doesn't require passwords, because it relies on either biometric data or private keys and multi-step authentication to ensure that the user is who they say they are. And these systems are not only more effective protectors of our information than the username and password, but they are easier to. So the future, biometrics, what you are. So leveraging on the blockchain makes it easier to implement and apply. I think we should look at another very good example is preventing attacks on automated systems. So today, a lot of experts now are relying on blockchain to recognize invalid or potentially corrupt commands and inputs. Setting such an automatic update can invalidly include malware, compromising your data, and even shutting down your system completely. So, but for the ability, based on the algorithms that you can set up leveraging on the blockchain, you can constantly, be checking to recognize, unrecognized or threatening intrusions that would allow, for the convenience of automation without the risk that comes with the lax manual oversight. So basically, we can't say that because of the risk that comes with automation that we won't leverage an automation for ease of doing business. Well, based on algorithms that we can set up, that will continuously monitor and track, and that would prevent any harmful malware that would come through. A very other important one is, securing DNS. So more secure DNS. Why this is important is, so the DNS technology and how DNS is accessed over time has been central. But now, leveraging on the blockchain that is completely decentralized by nature, would really help, has pushed, would really help the host, the DNS host, to leverage on a distributed setup. Basically, it means there is no single point of failure yet. So, and it means for an attacker to bring down or deny access to this DNS service, you'd have to hit the multiple points, multiple blocks, multiple instances, and build up the DNS service. And so the benefits of this is it will lead to a stronger, decentralized, secure DNS service that would represent the needed break from the partially centralized system that we are used to running today. And definitely it eliminates that single access point of vulnerability that we experience today. So I think we can talk about the other ones, but I think we should just delve right deep into how we can leverage, blockchain to mitigate DDoS attacks. So for me, this is quite exciting because, lately there've been a lot of DDoS attacks, denial of service, different businesses, even state level, national level, national infrastructure. And, so it's a bit troubling because controls are actually in place, but are the controls enough? And, the way it works is you put controls in place, then the bad actor too always looks for very creative ways to beat the controls in place. So the question now is, what will work best? Which controls can we put in place that would ensure smooth running of services, that would minimize downtime, that would ensure continuous availability of businesses and platforms? And, so it's very critical that we look at effective ways of preventing DDoS attacks. And the blockchain is one of the best ways to achieve that. So this is just a descriptive of typically how a DDoS attack works. An attacker online through his command and control center, infected systems, bots, creates a botnet, zombies the systems, controls the system entirely, uses them to attack different victims online, uses them to create a denial of service for different entities, different platforms, sending spurious traffic, overwhelming the system, overwhelming the host, and bringing down their service. This is how it works. But what are we looking at? We're looking at a scenario where leveraging blockchain in DDoS, we're looking at a decentralized system that would create millions of copies, encryption that will be provided for data security, and private keys used for communication based on the setup of it. So as you would see that now, as a customer, or even an attacker, you are coming to the service provider, you're coming to the platform, you pass through the blockchain system, it's decentralized. It's not a single point of failure. So for every node you hit, there are multiple nodes available to be able to still pass on that transaction and continue with the request. The blockchain is more secure, is more transparent, then is irreversible based on changes that have been made. And then, so you're sure there will be no man in the middle attack, there is no single point of failure, and there's no distributed denial of service. So for me, it's a very critical service, it's a very critical function. It helps be able to put stretch on your infrastructure, and you're sure that, At any point in time, your service can be continuously available. It also allows, users, it allows the user, which is the platform user or the platform owner, it allows you in the situation of an attack or a possible denial of service, it allows the user, join distributed networks that would serve to augment, the security of your own network coming under fire, which is coming under an attack. And this also includes the potential of users on your network, or your own network itself, your platform, to rent out and get extra bandwidth. So for example, it's a distributed network. So you are under attack, but you're on a network. You can actually get additional bandwidth to support your network, which is what, entities do today. You are under attack, so you increase your bandwidth. You increase your bandwidth to be able to sustain the attack. The attacker on the other side too increases the bandwidth of the attack to be able to overwhelm you. So it's a game of who's the heaviest, who's pushing the heaviest. So as much as you can stretch, as long as you're part of that decentralized network, you will be able to stretch into other networks and be able to get extra bandwidth to support your network that is currently being overloaded by traffic for denial of service. And this will provide a chance that the hackers will be rebuffed from causing the crash. So this continues until the hacker gives up and says, you know what, for every time they try to push and bring you down, you keep gaining more capacity on the spot. So this enables your network to be scalable. It enables your network to be able to stretch, from a bandwidth and load management point of view. So it sounds a bit simplistic, but the structure for me, I think it makes a lot of sense because the implementation might not look straightforward initially, but once achieved and applied, then you know that you have a more stable system, a more stable environment that can scale. So I picked an image from a blog I also always follow, and basically it's showing you how the DDoS attack comes through. And it's a bit funny image, but I like it because, funny enough, it's a bit more descriptive. And it shows you DDoS attack, leveraging on and preventing DDoS attack leveraging on the blockchain. So if you have the blockchain system compared to when you have the traditional DNS system running and how the attack, the threat model, the attack model looks like. So for the DDoS attack, you see a scenario where the zombie systems come at you, they come at the DNS service, and in a minute, depending on the amount of time, depending on the bandwidth, the DNS system gets overwhelmed. So at that point in time, a legitimate user trying to access the internet, check Facebook, or carry out work-related stuff, can't do anything, can't carry out any activities on the system because of the denial of service. This is what we're trying to prevent. This is what we want to ensure does not happen. But on the other hand, if it was built on the blockchain technology that is decentralized, multiple nodes, no single point of entry. So the first point of attack is just one node. Irrespective of the number of zombies, they all hit a node. Only a node is impacted. Multiple nodes are still available. Other users can still access the internet. Other users can still access the network. Other users can still access the platform and leverage on the resources that they need to know without even knowing about the attack. So this helps, capture the attack, sort of quarantine the attack to specific nodes. And there are other nodes available based on the decentralized nature of the setup. So it's a no-brainer for me, as in the decentralized setup will scale any day, anytime. And it's highly recommended. So what's the future of blockchain-based cybersecurity? For me, there's no going back. The blockchain can be utilized to prevent any type of data breach, identity theft, cyber attacks, false transaction, and sharing data privacy. So it gives complete visibility into activities, your network on your domain, depending on the security control that is used to define your flow. As the day passes, the rate of cybercrime, will continue to rise. The beauty of this is to create jobs for we cybersecurity professionals over the next few years. So for me, I believe the blockchain technology that will tend to be our savior, especially from a data security point of view. Why? Because of the process of validation and verification, and the cryptographic functions that is leveraged in the blockchain technology, and now it can be aligned with your security controls, go a long way in enhancing visibility and security of your network or your technology landscape. Cybersecurity will boost will be boosted double the amount of cyber criminal rates only when blockchain technology has been used as a minimum. So basically, it's saying we can, as the cyber criminals are coming, we need to also enhance our cybersecurity controls and processes. And leveraging a technology like blockchain would help overpower, at least to use, like almost lay terms, outnumber the adversary and be able to counter every attack that comes our way. So for me, let's look at beyond the elevation. Let's look at beyond the elevation. Let's embrace the blockchain technology because it's going to help us have a more secure data landscape for data secured world through blockchain-based cybersecurity. It would help enhance data security. It will help secure our infrastructure. It will help enhance visibility and transparency, in our networks, and on our technology landscape. So basically, I just included this to just look at future applications of blockchain, especially from a Web 3.0 point of view. So there'll be ability to create value and authenticate digital information. So what new applications would arise from leveraging the blockchain? Smart contracts, it's probably the most widely used functionality for the blockchain. So basically, distributed ledgers, they enable coding of simple contracts that will execute when specified conditions are met. So sharing would be easier, more transparent and secure. Crowdfunding would be trusted because it's an open platform and it can be tracked effectively. Governance would be smooth because votes, for example, if it's for voting, votes would be publicly accessible. Distributed database technology could bring transparency to elections. So the issue of ballot hijacking or manipulation of votes in the elections won't. There's a major advantage for supply chain, file storage, most importantly. So for file storage, we'll be looking at decentralizing file storage. I think so. I've seen a lot of write-ups on that, and the idea is it would help not let you have all your critical data and information in one place. So if that single point is breached, then they have access to all your data. It ensures the spread of your critical data and information across multiple storage platforms, leveraging decentralized model. Prediction markets, basically for the algorithms, machine learning, artificial intelligence, securing intellectual property using smart contracts, securing for the Internet of Things, securing IoT devices. Smart contracts can automate remote systems through combination of software sensors. Microgrid, that's power for communities, anti-money laundering and KYC. I read an article about JP Morgan and I think Barclays. They're already leveraging blockchain to improve the effectiveness of their KYC process to know their customers and their anti-money laundering efforts. A very important use that I think I've been hearing entities talk about locally here is land title registry. There are always issues with land title registry, which is the details are always altered, information changes over time. But with leveraging on blockchain technology, it's transparent, it's open, and details cannot be altered once set. And also, it's transparent because it's open to the public and it can be altered. So it goes without saying that the benefits of the blockchain definitely signs it up as in it scores it really high to be applied and implemented for blockchain, for cybersecurity. And the more we embrace this, the better it will be for us, knowing that we can achieve trust, we can achieve reduced cost of implementation. Most importantly, we can achieve transparency and security. And the major feature of the blockchain being a decentralized setup is, from a security perspective, is there is no single point of failure. Eliminating the single point of failure makes you a better cybersecurity specialist. So I believe as we go and as we leverage on the blockchain, we'll be able to implement better controls and put better processes in place from the cybersecurity. So thank you very much, and I'm open to taking questions if there are any. Thank you for having me here.